So in this video, we're going to look at more to our rational exponents and evaluating expressions with variables. So you can write a rational expression as a root or vice versa, or you can simplify expression with all rational exponents that contain numbers and variables. So again, remember rational exponents, fractions as powers in the exponent expression, like 8 to the 1/3 or 4, or y to the 4th third, that just means it is a root. And then remember how we rewrite them. This is your index, the numerator is your power, and whether it's a fraction or just a single expression. Remember, the order operations does not matter. We can either write it like this, or we can do the root first and then the exponent. And this is actually easier, we found. It's easier to go smaller than bigger. Also recall your exponent rules. We're still in the same unit with exponents, and we're going to apply these rules today to help us simplify expressions. So we want our power to a power rule, where we end up multiplying our expressions. This is x to the mn, or we have x to the mn over y to the pn. Here when we have the same base and we're multiplying, we add the exponents, how many x's we have. Here we subtract, how many do we have more on top and bottom, and then we have a negative exponent. It moves the expression. Alright, so we're going to write the radical expression using rational exponents, and then we're going to use our exponent rules to simplify. So here, our base is x, our numerator is 6 to the 1/2 power, or 2. Well, if you have a fraction that you can simplify, go ahead and simplify it. So this is x to the 3rd. I only have one base the same and one exponent. It's positive. I am done. Here, I have h to the 15th, g to the 9th as my base, because that's the entire radicand. And then 3 is my exponent, so that's to the 1/3 power. Well, here we have power to a power. We have powers, and we're taking to another power, so I need to multiply. So I go 1/3 of 15, which is 5. 1/3 of 9 is 3. Or you can think of it as 15 over 3 and 9 over 3, which simplifies down to 5 and 3. We have one of each base, and all our exponents are positive, so we are finished. Here, it's already written as a rational exponent, so we don't have to do the first part. And then we have power to a power, so I can distribute. So 1/2 of -4 is a to the -2. 1/2 of 8 is 4. Are we done? Well, we have different bases, which are okay. We don't have any repeats. However, I have a negative exponent, so we know our negative exponents means it needs to move. It's in the numerator. It needs to move to the denominator. Now we are finished with the problem. So on D, I have my base, and this one, x to the 10th, y to the 20th, and that is to the 1/5 power. So this one's kind of like a separate problem, and then this is a separate problem, and then we're going to put them together, times, we have x to the 4th, y squared, and that is to the 1/2 power. Well, I can do power to power. I can distribute the 1/5 times both. So that's x squared, y to the 4th, dividing both of these by 5, times 1/2 of 4 is 2. 1/2 of y, or 2, is 1, or just y. Now, on this one, I have two sets of x's as my base, so I need to put them together. So this is 2 x's, 2 x's, so I have a total of x to the 4th, and I have y to the 4th, y, so that is y to the 5th. Alright, so our last two examples. Here we have a fraction, and again, I'm going to kind of treat them as two separate problems and then simplify. So c to the 16th and d to the 8th is my base of my exponent expression. And then to the 1/4 power, and then on the bottom I have c to the -3 and d to the 6. I have no root, so I'm just going to leave it for now. I can distribute that 1/4, so c to the 4th, d squared over c to the -3, d to the 6. Alright, I know I am not done. I see a negative exponent for 1, and then I have sets of d's and sets of c's. Well, the negative exponent would move up. It should be c to the 3rd, c to the 4th, and then my d's would stay. And then I can combine together if I can. These two are both in the numerator, so how many c's are in the numerator? Well, that's 7. 3 plus 4. And then I have d's on top, so remember d over d. And then we have 6 d's on the bottom. 2 of them simplify to 1, so I'm left with d to the 4th. And bringing back those exponent rules. Alright, so and then the last example, here this is already written as an exponent rule. So I can simplify, this is g to the 3rd, and then 4 times 9 is h to the 36. Here I have g squared, and then h to the 8th to the 1/2 power. That can be written because that's h is my base, my exponent is 8 in the root, which is h to the 4th. I have all positive exponents, so I don't need to move anything. And then I can simplify. I have 3 g's on top, 2 on the bottom. 2 can simplify with 2 on the top, so I have 1 g on top. I have 4 h's on the bottom. I take away 4 from the top, and that's h to the 32nd. Alright, so remember all your exponent rules. This is going to be a great section to help you remember before your Unit 3 test. And then just take it one step at a time. Don't try to rush through it or think it too much. That's when mistakes are made. It's a reminder to do a reflection so you get credit for watching this video.